Hi, my name is Dr. Kamba. In this video, I will be discussing unit root in time series data. Unit root is a characteristic of a time series data that makes it non-stationary. A data is said to be non-stationary if its statistical properties are changing over time, that is, they are not constant. What are these statistical properties? They are basically three: the mean, the variance, and the covariance. So this implies that when the mean, the variance, and the covariance of a time series data is constant over different time period, then that data is considered to be stationary. Researchers, especially in the field of economics, are more comfortable using stationary data in econometric analysis because it is assumed that results from the analysis of such data will be reliable and this will inform good policy decision. If, however, the mean, the variance, and the covariance of a time series data are changing over time, then the data is said to be non-stationary. A non-stationary time series data contains unit root. The problem with using data that contains unit root is that results from the analysis of such data is likely to be spurious or nonsensical. So this implies that apart from the fact that the result of analysis of that data is not reliable, it will also be very difficult to make forecast into the future with such result. Therefore, all policy decisions that emanate from the analysis of the result of a non-stationary time series data are likely to be misguided. All right. We say that the mean, the variance, and covariance of time series data, whenever they are changing, the data is stationary. The data is non-stationary, but whenever they are constant, the data is said to be stationary. What does that mean? So let's quickly go to raw data to demonstrate how raw data can be used to determine the stationarity or non-stationary status of a time series data. Before then, what is mean? What is variance and what is covariance? In time series data analysis, the mean of a variable yt is its expected or average value. And this average value is calculated by taking the sum of all observations and dividing it by the total number of observations. So if we have time series data yt and data on yt were collected for the period y1, y2 up to yn, then the expected value of yt is its mean and is defined as the sum of y1, y2 up to yn divided by the total number of observations. Variance, on the other hand, is a measure of spreadness of the numbers in the data set. It measures how far away from the mean each observation in the data set is, and also how far away each observation from the data set is from every other data in the every other number in the data set. So suppose you have y1, y2 up to yn observation, the variance is calculated as the sum of square of the difference between each observation and its mean, then divided by the total number of observation. The covariance, or what is sometimes called autocovariance, measures the linear dependence between 2 points at different times, and it is calculated by taking the sum of the product of the difference between each point and its mean value, then divide it by the total number of observation. So let's quickly go to our raw score to demonstrate what we mean by stationary and non-stationary time series. Here, there are two things here. We have the time the data is collected, and the time ranges from 1960 up to 2020. Okay. Then the second thing is the variable on which data is collected. This is GDP per capita, that is per capita income, which I denoted here as YT. And data is collected on YT from 1960 up to the year 2020. So now, how do we know by mere looking at this data whether it is stationary or not? There are unscientific ways to do this. So one of it is, first we are going to calculate the mean of this data, and then we check if the data the mean has been changing or it has been constant throughout the period of observation. How do we do this? Well, first of all, split the data into various time or what is called data points or components, with each component having equal interval or number of observations. For example, I will choose from 1960 to 1964 and calculate the mean, and this will give us one data point. I have it here. I have 1960 to 1964. This is 5-year observation from the main observation. Then we calculate the mean of this observation. Okay, look at the mean here. We calculate the mean. Okay, it's coming up. Okay, now this data is from 1960 to 1964. This is the sum of the data from 1960 to 1964. This is the summation. So we divide the summation by 5 to get the mean. Since we have 5 years observation from 1960 to 1964, the sum of this observation divided by 5 gives this mean. So this is mean of the variable YT from 1960 to 1964. Now, from 1964 again to 1968, another 5-year observation gives this mean value. From 1968 to 1972, another 5 years observation gives this mean value. From 1972 again, up to 1976 gives this mean value. Again, from 1976 to 1980 gives this mean value in that order. So if we look at the mean for the various data points with equal interval, we realize that the means are not the same. That is, they are changing over time. Okay, now we also computed the variance to see if the variance of this data are constant or they are changing over time. This is the variance here. Where is the variance? Okay. From the formula for obtaining the variance, now this is YT 1960 to 1964. That is the first data point where we calculated the mean to be this. Now, what we did here is to import the data to this place. This is the YT. This is YT minus mean. This is YT minus mean square. And we now divide YT by mean square by 5 to obtain the variance for the 5 data points. This is the variance here. So you can see that for data that covers 1960 to 1964, this is the variance. So let's look at the data that covers 1964 to 1968. This is the variance. From 1968 to 1972, this is the variance. So if you compare these variances, we realize that they are also changing. Therefore, since the mean, the variance, and the mean and the variance of YT are not constant, that is, they are changing over this period of observation, we have reason to conclude that the variable YT is not stationary. In other words, it does not exhibit similar behavioral characteristics throughout the period of observation. However, what we must note here is that using raw data and looking at the characteristics of the data to tell its stationary status may be misleading. In other words, we are trying to say that we have demonstrated this just to enhance our understanding of what we mean by changing mean or constant mean, what we mean by changing variance or constant variance over time. However, it is not all encompassing. We cannot use this analysis to judge whether or not YT is stationary unless we carry out a formal test of stationarity using any of the available software. However, we can also run the trend analysis of this data to find out whether the graph will trend upward or downward, or it does not have a specified discernible pattern. This can also help in telling us the stationarity status of the data. Okay, now let's go back to these are some of the factors that could cause the mean, the variance, and the covariance of time series data to change. We have trend, we have cycle, seasonality, irregular, or white noise. So trend is a characteristic of time series data that shows that the variable on which the data is collected is rising or falling over time. So here you can see this is a trend. Okay, this trend is an upward trend, while this trend here is a downward trend. This is seasonality, or rather a cycle. A cycle is a sequence of smoother fluctuations around the longer time trend, characterized by alternating periods of expansion and contractions. This is a cycle. This is seasonality, when factors such as time of the year or day of the week affect the dependent variable, repetitive patterns are observed in the series, and this creates a kind of seasonality in the time series data. Then we have irregular. Irregular fluctuations occurs due to random or unforeseen events. They are of short duration and non-repeating. So, e.g., we have coronavirus, Ebola pandemic. All these are shocks that occur in the economy, and they could create irregular pattern in time series or irregular movement of the time series data. Then we also have white noise. And white noise is a random fluctuation of no period at all. It has a mean of 0 and constant variance and has no correlation. So this is how the graph appears. Okay, in our next series, we're going to look at how softwares, eView in particular, is used to carry out the unit root test of stationarity. Thank you very much. Don't forget to share, like, and subscribe. Thank you once again.